Section 3.4 Derivatives as rates of change. Number 6. The position of a body moving along the s-axis is given by this function s of t equals t to the third power minus 12t squared plus 36t, where t is the time in seconds and s is the length in meters. We want to find the total distance traveled from time t equals 0 to t equals 4. So we need to understand what is the distance mean. The distance, by the definition, is the full length, so total length of full length traveled by the object, and it's different from the position function or the position. So what is the difference? So let's take a look at the s-axis. Okay, so s-axis. We're talking about a line right here. So at time t equals 0, okay, so t equals 0. And how far the particle travel? Along the x-axis, it travels 0 distance, 0 meter. Okay? Now, what about when time t equals 4? So when t equals 4, so s of t, s of 4, you plug in 4 cubed minus 12 times 4 squared plus 36 times 4, you get 16. So what it's telling us is at time 4, the particle is 16 meters away from where it started. So the question is asking for the total distance traveled. It's not simply just, from where it began to where it stopped, 16. Because that is just the displacement. Because if you were to look at s equals 2, okay, so you get 2 cubed minus 12 times 2 squared plus 36 times 2. So you plug it into a calculator, you get 32. What it means is that at time t equals 2, the particle actually is at 32 meters away from where it started. So what it's telling us is that it's traveling along the s-axis this way, and somehow it go back and end up at the 16 meters away. So now our job is to find the total distance. So what we need to do is add the length of the green piece and add the length of the red piece. But we need to find out where they stop. Okay, where the particle is changing the direction. So hint or the key is to find where or when it changed direction. Now you can also plot the position function against the time. Okay, so this is time, this is s. And we plot this function using a calculator. Okay, you can think of it as the x and y axis similarly. So you can find out at time equals 0 and time equals 4, the function looks like this. And if you continue plotting, right, the rest of the function is going to look like that. But we're only interested from 0 to 4. You realize at some point right here, so the displacement is increasing. So I'm going to use a green color. It's increasing or going away from where it originally is and then going backward. Okay, so we need to find this point where it changed direction. Now, how do we find the point? You need to think about when something is moving in one direction, what must happen for it to change direction? So it has to have a velocity v of t equals 0, it had to stop in order to change direction. So this is the key to answer this question. Okay, so we use our knowledge of the relationship, okay, s prime of t will equals v of t. Okay, the derivative of the position function is the velocity. So then we find out the derivative. What is the derivative? If you take a look at the function t to the third power, the derivative is power comes down, power decreased by 1, okay, minus 12 times 2t, right? So 24t plus 36t, the derivative is 36. We want this, the velocity, to equal 0. And just solving this polynomial, so you factor it out. You factor out the 3, you get t squared minus 8t plus 12 equals 0. Then you think about the factoring. Okay, so t and t. What two number you put in there that they multiply to 12 and they add up to negative 8. And those two numbers are negative 2 and negative 6. So it tells us that when t equals 2 or t equals 6, the particle change direction. But because we're talking about the interval 0 to 4, we find out this point that we're talking about is at 2. So what it's telling us is at 2, the particle is going away from where it used to be, but then it changed position, so it's going back toward its origin. So this is how you solve the problem. Now, in order to find the distance traveled, we need to find, okay, what is the blue piece right here? Okay, how do we find it? The distance for the blue piece is the displacement s at 2 minus s at 0. Okay, it's from the difference between the displacement, okay, where it originally is and where it end up. So how far apart are they? Is 32 minus 0, which is 32. Now for the red piece of the distance, is from s of 2 to s of 4, okay, or s of 4 minus s of 2. But again, we want the absolute value because those are negative, going toward the negative direction. So we just have to find out is 16 minus 32 in absolute value. So that is 16. Now, then we can answer the question, what is the total distance traveled? Then is the distance that it traveled at the positive direction plus the distance it traveled at the negative direction right here. And you get 48 meters as the answer.